In this video, we're going to set up a DynamoDB database, run queries on that database from the AWS console, then set up a Python application that connects to that same database and performs operations on it using production-ready best practices. By the end, you'll have a complete working system that you built yourself. Before we dive in, please make sure to hit that subscribe button so that you can stay current on all of my cloud content, and let's dive right into it. The first step is to set up a DynamoDB database, and we're going to be doing that from the AWS Cloud Console. So make sure that you're logged into the Cloud Console as some user that would have the privileges to create a DynamoDB database. If you don't have this basic setup, I'll leave you a link inside the video description that takes you to the AWS setup tutorial. Make sure that you go through it, it's quite short, and then come back. All right, if you do have this basic setup, let's just go ahead and create the DynamoDB database. Oh, apparently I can't spell. There you go. Okay, so DynamoDB provides a NoSQL database. A NoSQL database is one where each entry is a JSON document with key value pairs. Nothing more. What's very unique about DynamoDB is that it's fully managed, meaning that you don't have to provision any of the underlying infrastructure yourself. All of it is set up for you, and you simply pay for however many requests go to your database. If you get 10 requests per second, you pay for those 10 requests. If you start getting 1,000 requests per second, AWS is going to auto-scale your database to meet those 1,000 requests, and all you have to worry about is simply paying for those requests. You don't need to manage any of the underlying infrastructure yourself. With a simple click of a button and filling out a bunch of fields, you have a fully managed database service. Okay, now creating a DynamoDB database is very, very simple. You simply have to specify the table name, as well as a primary key, which is a combination of the partition key and sort key. I'll explain what those are in just a second. Starting with the table name, a table is a simple collection of JSON documents, nothing more, nothing less. I'll link you to this GitHub repo in just a second, just bear with me. This table is going to be storing JSON documents where each one represents a user profile. It follows that I'm going to name this table User Profiles. Simple as that. Now, how do we set up the primary key? The primary key is composed of two keys. The partition key, which is used to initially partition the data. And once that data has been partitioned, segmented, the sort key can be used to uniquely identify a document within that segment. The combination of both of these is a primary key. So, what do we use as the partition key? In this case, we're going to use the user ID. All right, I'll explain why in just a second. If I decide, so this allows me to now query all the data based on user ID. And if I decide to query based on the user ID 123, it partitions the data such that now we have two documents in the partition that we just queried for, and one document gets omitted in another partition. Now within this partition, how can I zero in on a specific record? Well, in this case, you need to use a sort key whereby the field is unique across every record in this partition. And this would have to be the timestamp. So by doing this, we've now set up a primary key that is capable of uniquely identifying every single record in this whole database, whereby the partition key first partitions the data based on a specific field. In this case, assume we queried for user 123, and then the sort key, which is unique across every record in that partition, allows us to zero in on a specific document, because we assume the timestamp will never be the same from one document to another in the same partition. So that's the primary key. A primary key is a unique identifier for each item in your table. Okay? It is the combination of partition key and sort key that makes this possible. All right, let's scroll down and go ahead and create our table. Simple as that. All we had to do was specify a table name, primary key, did not have to set up any infrastructure at all. All of it is done for us. We now have a database that can now scale automatically with increasing demand. All right, go ahead and click on your table. And we're going to start by exploring table items. All right, this will allow us to start creating some documents. So what I'm going to do, instead of copying and pasting JSON fields one at a time, go to the JSON view. Instead of view DynamoDB JSON, make sure that this is switched off so that you can copy over the JSON from this repo. I left you a link to this GitHub repository inside the video description. Make sure that you go to it now. We're going to clone all this code later. For now, just use the following resources to create 3 records in your DynamoDB table. All right, first one creates the document with user 123. Simple as that. Create another document. Pardon the indentation. I made this in pretty fast. Create item. All right, go ahead. Uncheck the following. Okay, all right. And now we can go ahead and run some queries to see how everything works. Notice that it starts off with scan. What scan can do is it can scan every single document in your table, and you can see how, if this had millions of records, how expensive this operation would be. So ideally, what you want to always do is query based on a primary key, whereby the partition key can be used to partition the data, in this case based on a user ID. So if I partition the data based on the user 123, I get the following partition. All right, and based on the following query result, I can use the sort key to zero in on a specific record within this partition. So if I use the following timestamp, which is unique to this record in this partition, the combination of this entire primary key identifies a unique record in that whole table. All right, so if I reset and run a scan, I get every single record on this table. And this is the perfect time to introduce another use case. So why do we always start our query based on the partition key? That's because if you're familiar with hash tables, this is actually very similar. DynamoDB hashes each partition key so that when you query it later, it knows exactly which partition to give you. So if I enter user 123, this is already hashed into the system, and it doesn't necessarily need to query in the sense that it knows to automatically give you this partition at 100% efficiency. But now, what if I try to query based on something that hasn't been hashed, based on something that effectively isn't the partition key? So if I try to query based on email, let me go ahead and reset and rerun this scan. If I try to query based on the email attribute that equals the following value, notice the efficiency drops a lot. Why? Let me reset. The email field is not hashed. So when you provided the email, whatever, DynamoDB doesn't know where to start looking in order to give you the partition that you're looking for. it's not hashed. So it needs to scan your entire table until it finds every matching record for this email and then give it back to you. This is really, really, really bad and really inefficient. So how do we remedy this? What if out of nowhere we also need to query based on this email, but it's not part of the partition key? What you would need to do is let's rerun the scan, and then go back to our table. All right, click here, click on indexes, and what we want to do is create a secondary index. And what this allows us to do is create a global secondary index, meaning we had our main table, which we could query based on the primary key, but now we create a secondary index whose data can be partitioned based on another field. In this case, we're going to choose email, giving the entire index a name of email index. All right, so now we have basically two sources we can query from: the main table with the primary key, the separate index with the email key. So if we go back and explore table items, giving this sufficient time to create, hopefully it's created by now. Let's go to query, and now I can query the separate secondary index based on its partition key, email. So it was able to hash this partition key in order to know which partitions to look at instantly. So now I can query based on the email, user123@example.com. And this is done at 100% efficiency, as opposed to the scan operation, which was wildly inefficient. All right, and that's it for that. Now the next step that I want you to do is go back to the Git repository. Remember, the link is inside of the video description, and clone it. So go to your terminal, whatever terminal you like to use, go to any directory where you want to clone this project, and then say git clone, clone it, and that's that. Go ahead and launch it. I've got mine right over here. Okay, let's get set up. And before we dive into this, there's one important thing that you need to have set up. Write the command on your terminal or whatever, AWS configure. And I'm just going to keep pressing enter. If you get command not found, or if your access keys aren't set up, that means your CLI, your AWS CLI, is not configured to connect to your AWS account. If you don't have that set up, please go to my AWS setup tutorial now. Again, link is inside the description. Click on that Start Learning button, create your AWS account, CLI, whatever it is that you need to do, but do make sure that you've got your AWS CLI configured and connected to your cloud account. Pause the video and do that now. Assuming you've got that configured, the Python app you're running is going to rely on the configuration from your AWS CLI in order to connect to that same cloud account. Once connected, what this application is going to rely on is an AWS SDK called Bot03, an SDK that's specific to Python, to then connect to the table we created, user profiles, with a secondary index, email index, in the AWS region, US East 1. So do double check the region where you were deploying all of your resources. For me, it's US East 1. For you, it might be something else, so do make sure that if it's Ohio or North Carolina where you deployed your resources, to replace it as such, okay? Otherwise, it won't be able to find your table. For me, it's US East 1. I'm going to go through with it. So I'm going to go ahead and open up a terminal. There's a terminal option on top over here, but you probably can't see it. You can see it on your own menu. Now, I want to note that although we're doing this example for Python, there is an AWS SDK for any platform, be it JavaScript or Java. So once you learn the steps for Python, they can be scaled to really any platform. All right, so we've got everything that we need in order to run this app and have it connect to our DynamoDB table. It's going to inherit the configuration from our AWS CLI in order to connect to the cloud account. Once connected, it's going to find the specific table user profiles. And upon running this script, what I set up for you are a bunch of operations where it adds a user profile, where it gets a user profile, where it queries their activity field, so on and so forth. So what I want to actually start off by doing first is, let's go ahead and scan everything, grab every record, and delete it. And so if we go back, I left you with a ton of operations, a comprehensive amount of operations that you can always use for your reference. The first one grabs all of the data from a JSON file and simply loads it onto your table, effectively recreating the data we just deleted. So just to give you a sneak peek into this function, I'll let you look through it on your own later on, but it effectively just loads all the data from the file, loops through each item, and uses the following method to put the item. Nothing too crazy. We're effectively just redoing everything we did in the Cloud Console, but through coded operations. So this adds another user profile. This gets a user profile based on a primary key, so on and so forth. And here are many more operations that you have at your disposal to recreate for your own projects. And this can be done for any platform, be it a Java app, a JavaScript app, so on and so forth. The final thing we want to do is actually just run this so that we can see results. And there's two ways to run this app. There is the boring way and the fun way. If you want to do the boring way, the easy way, all you got to do is install the dependencies that this app relies on and then run it. But this involves installing Python on your local machine. I'll leave you a link to this in the video description if you choose to do it the boring way. Download Python. That's going to install pip as well, the package manager. That's going to be used to install all the dependencies over here. And you can do that by saying pip install -r requirements.txt, installing all the dependencies, and then you can just say Python dynamoapp.py. It's able to load 3 items, it's able to add another item, retrieve items, so on and so forth, delete an item. All right. Now, if you wanted to go ahead and check, let's just do a scan, reset. We have 3 items, 3 were loaded, another was added, 1 was deleted, checks out. And you know what? I think I'm going to stop the video right here. What I was going to do next is actually run that same code from a Docker container. The advantage of that would have been is instead of installing Python on our host machine, we could have installed it in an isolated container that we could have then been able to destroy later. That means you would only have Python installed for this project, and then you could clean it up afterwards. That's the advantage of using Docker containers, among many. And so if you are not familiar with containerization, highly recommend you check out my Docker course. I'll leave you a link to it in the video description, and I'll see you in the next one.